Welcome back, guys. Today I'll be doing partial differentiation, and next week I'll be looking at complex numbers. It is coming from CAPE Unit 2 Past Paper 2, Year 2017, and I will be doing question 1B, partial differentiation, and next week I'll be doing 1C, which is complex numbers. Let's get started. Here we have a function w is defined as w being a function of x and y, where we have ln, and then in the numerator 2x plus y, the denominator x minus 1, and we find the modulus of this. Now, given that the partial derivative with respect to x is equal to 1 over negative 9 at the point 4y, calculate the value of y. Now, let me rewrite w, which is a function of x and y. We can express it as a difference because here log rule says when you divide, we subtract. So we can write this as ln 2x plus y minus ln x minus 1. And having this, I can use the information where it states the partial derivative with respect to x is equal to negative 1 over 9. So it means I need to find the partial derivative with respect to x. So wherever I see x, I differentiate, and y is a constant, so it becomes 0. And differentiating this log rule, it becomes a fraction, so you differentiate inside the modulus to get 2. The y becomes 0, 2x becomes 2, and then you rewrite the denominator, which is 2x plus y. Same scenario here, differentiate x minus 1 to get 1, and then we rewrite the denominator to get x minus 1. Having this, we know that the partial derivative is negative 1 over 9 along with the points x is 4, and we're finding y. So replacing here with a negative 1 over 9, I'm going to have negative 1 over 9 here. And here I'll rewrite it as 2 over 2x. But x is 4, so I replace x to be 4, plus y minus 1 over x again is 4, so I have 4 minus 1. Now 4 minus 1 is 3, and 2 4 is 8, so I can simplify this. So it's 2 over 2 4 is 8, so I have 8 plus y minus 1 over 4 minus 1, that's 3, so that's 1/3. Now this constant, we can carry it over to the left. So grouping the like terms, so I have negative 1 over 9 plus 1/3. And it's equal to 2 over 8 plus y. Now, negative 1 over 9 plus 1/3, let's find the LCM. The LCM is 9. 9 into 9 goes 1 time, so 1 times minus 1, that's negative 1. And 3 into 9 goes 3 times, so 3 times 1, that's 3. So minus 1 plus 3, that gives me 2, so I have 2 over 9 is equal to 2 over 8 plus y. And for this, I can cross multiply. So cross multiplying these two, I will get rid of the denominator. So 2 times 8, that's 16. 2 times y naught, that is 2y naught. And equal sign, 2 times 9, that's 18. Now carrying the 16 over, it becomes negative. So I have 2y naught is equal to 18 minus 16. So that will give me 2. So I have 2y naught equal 2. And I divide both sides by 2. So this cancels, so y is equal to 1. And that's it. Now the next question states, show that the partial derivative, but we are going to differentiate 2 times with respect to y and x, minus 2 partial derivative, but we are going to differentiate it twice again with respect to y. Now, just a reminder, what is wxy, which is a function of x and y? It's ln, but I'm going to rewrite it as a difference, which is ln 2x plus y, and that should be modulus minus ln x minus y. Now, let's look at the first part. I am going to first find the partial derivative with respect to y. That's what I'm going to find first. So the partial derivative with respect to y means I am differentiating, and where I see y. So looking at this, differentiate the inside. This is the y. So I differentiate to get 1. 2x would be 0. So I'd have just 1 over 2x plus y. Now the next part doesn't have any y, so it means when I differentiate it, it will be 0. Now I need to do the next part, which is finding the partial derivative with respect to x. So I'm differentiating this one more time, but with respect to x. Now you can use quotient rule, but I can rewrite this so that it's no longer a fraction. So this will become 2x plus y all raised to the negative 1. It's like a 1 being raised to the power on 2x plus y. So rewriting it, it will become 2x plus y. When you carry it upwards, it becomes negative 1, indices rule. So differentiate using chain rule. Differentiate the inside to get 2. Differentiate the outside, so we carry the negative 1 in front. And then we subtract 1 from the power. So I have 2x plus y raised to the minus 1, that's minus 2. Now, just to remember, I can simplify further. 2 times negative 1, that's negative 2. And along with this, in my next line, because I have the negative 2 as a power, I can rewrite this as a fraction because of the negative power. So this is the same thing as minus 2 all over 2x plus y raised to the positive 2. So because we carry it in the denominator, we have a sign change. So the next part I need to look at is finding the partial derivative with respect to y twice. I already have the partial derivative for y, and I need to differentiate it one more time with respect to y. That will give us a second derivative, and it's a second partial derivative. So I'll be differentiating 2x plus y raised to the negative 1, but I'll be differentiating y. So differentiating the inside, I will get 1. Outside, I carry the negative 1 in front, and then take away 1 from the power. So I'll still have the 2x plus y, but subtract 1 from the power, so it becomes minus 2. So 1 times negative 1, that's negative 1. Then I have 2x plus y raised to the minus 2. Once again, because I have the negative power, I can rewrite it so that it becomes positive. So it's negative 1 over 2x plus y raised to the positive 2. Now I can substitute into the part that they say show. So I'll be rewriting this part. So substituting, I have this to be minus 2 over 2x plus y raised to the positive 2. So I'm just substituting minus 2, and then for this other part, I'll have negative 1 over 2x plus y raised to the positive 2. Now I can simplify, because minus 2 times minus 1, that's positive 2. So I will have minus 2 over 2x plus y all square, which is raised to the positive 2, plus, because the sign changed, so it's plus, and I'll have the same exact thing. So as you can see, they're exactly the same, so that means it's going to cancel, and I will get 0. So therefore, proven. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And remember, part 2, complex numbers, is coming next week.